This is basic math, lesson number 2. First step is, of course, print these notes, read them, do the quiz. You know the drill if you went through lesson 1. That's the first thing. Then come back here and listen to this wonderful lecture on how to do all this stuff. Order of numbers. Numbers are ordered relative where they're positioned where 0 is. So numbers to the right of 0 called positive numbers. And if numbers are to the left of 0, they're called negative numbers. On a special note, I want to talk a little bit about what are variables. Variables are letters from the alphabet, A, B, C, X, Y, Z, that are used to represent a number. For example, I can say, let A equals 4. You might say, well, wait a minute, A is a letter and 4 is a number. You can't say one is equal to the other. Well, I'm not saying a letter is equal to a number. A, I want to call that a variable. And variables are unknown numbers until you can make them known. And if they're known, then I can actually make this assignment. I want to say A equals 4. Or I can say X equals 5. And now with that, I'm being more general. And that's pretty much what algebra is all about. We generalize the rules of arithmetic and lower level math into something that's more generic, that has basically the same properties. So I'm going to be using letters now that represent numbers sometimes from now on. Okay? So if I'm going to say A equals 4, let's talk about equalities. A number is equal to another number if they have the same position on the number line. So this A is 4, and I'm saying, okay, well, this is 4 right here. And this A is equal to it, so A is right there. A is 4. And I can say, well, here comes along B. And I'm going to say, well, B is going to be this same value. It's that same point. Oh, what can we say about that? Well, I can say A is equal to B. And that's all what equalities are all about. A number is less than another number if its point on the number line is to the left of the point of the other number. So in this case, I can say A is less than B. Now, the beauty of mathematics is that I don't want to keep writing is less than all the time. We have symbols for that. A is less than B. A number is greater than another number if its point on a number line is to the right of another number. In this case, A is considered greater than B. I switch them around. But I still want to say A first and then B. That's why I switched them. So again, I can write the words out. A is greater than B. But again, we have symbols for that. A is greater than B. Now here's a hot tip. It's kind of easy at first to confuse these symbols. Well, which one should you write when you're writing down numbers? Which one's a less than, which is a greater than? Very easy to figure that out. Here's the tip. The word less than, see, look at the L here. I can make that like the less than symbol. Okay? Also, here's a little something I learned when I was in grade school. If you have two numbers, let's say 3 and 5, and I want to say 3 is less than 5, okay? I want to use this symbol because I'm going to pretend this is like a little bird, and the birdie always wants to eat the bigger amount of food. So he wants to munch on the 5 here. And that's kind of cutesy and stuff, but it works. Now just make sure you don't actually draw the bird on the test. Okay, so and it works the other way around. If I have 2 is greater than 1, you see again the birdie is going to eat the bigger amount of food. Right, so that's something that might help you out. Memorize this. In your notes, there's a small table of different symbols that compare one value with another. You have equals, not equals, approximately equals, and so on. Do take the time to read through this. There's no really sense to putting on the board here because they're right there in the notes. And you need to memorize these notations. That will help you out in the math class. Interval, inequality, and set notation. This part of the lesson deals with how to properly and correctly write down different types of notation that represents a span of numbers. What do I mean by that? Well, let's say I want to somehow represent all the numbers that are between 1 and 3. On a number line, that's easy to do. All I need to do is just, something like this. See, I shaded in my number line. I made a little bit thicker line. Now, at home, you can do some razzle-dazzle graphs like this, at least most people can. So how would you just write it out? It's simple, like this. If you have a number line, hopefully straighter than that, and I have the numbers 1 to 3, and I want to represent the region, the span of values between 1 and 3, all I need to do is just something like this. Just shade it in, just make it a little bit thicker like that. Okay? That's it. Now, some professors make you do the following. Instead of this little shaded region, they make you do something like that. I hate that. No, don't. I mean, if they insist on it, of course, they're the boss. I'm just here to help you. But I personally feel that's a very poor notation. It's not very clear. The thicker shaded region is very precise, very clear. This is from here to here and there to there. Okay? Now, what happens exactly at 1 and 3? Are we including these values? Are we not including it? See, it's a little vague as it stands, even though we know this thicker part means everything between there. Well, I want you to memorize this. It's a little table. I have a more detailed version of this on the notes, but just in a nutshell, this is what we need to do. If you see on the test, or quiz, or your notes, or books, these two symbols, the less than or greater than symbol, we're going to be doing something. And if you see the less than or equal to symbol, or the greater or equal to symbol, we're going to do something else. Well, what? Well, on a number line, okay, I'm going to throw in an open dot. Okay, let's go ahead and erase that little part right there, which you would also on your test. If these symbols of equality, it's equals, it can be the dots, it can be the value, then we're going to represent that with a solid dot. Okay? Next, this is the graphing notation. Okay? This right on top here is inequality. Now, how about interval notation? For intervals, wherever that is, we haven't really talked about that yet, but we're going to be using parentheses to mean an open dot or less than or greater than symbol. We're going to be using square brackets to represent the actual value. It includes it. The dot's there. It means equal. Okay. Now, there's one other thing. Let me erase part of this right here. With interval notation, a value can go on forever. Much like these reviews. I'm just kidding. If a value goes forever, definitely to the negative values, you say it goes to negative infinity. If a value goes forever to the right, to the positive values, you say it's positive infinity. But for positive infinity, you don't put the plus sign. Just say infinity. And when you use the infinity symbols, you must use always, always, always parentheses. Okay? And professors are just waiting for you to put a bracket, square bracket like this on an infinity. Don't go there. Okay? So, this is a very handy little chart. Let's actually leave that there for now for the remainder of the session. And in case we need it, there is a very sophisticated table of information that I really want you to take the time to look over and memorize to the best of your abilities. Now, I don't mean memorize word for word, but just what do the graphs of the number lines look like or associated with the interval notation, which is another column, versus inequality and set notation. Okay, it's all laid out there. And it also tell you how to read. Now, obviously, if you're writing a test, you don't read out the questions, you don't read out the notation, but it's good to know how to do in case you have to talk to someone over the phone or you're discussing in class with your professor. Let's look at this interval right here on the number line. We have a -3, we have a 1, we have a solid dot here, an open dot here, and I like to create what's the interval, inequality, and set notation for this number line representation. How can we do that? Well, this is where this little table comes in handy. Okay, for interval notation, the key is again to go from left to right. I see a -3, so I'm going to write that down. Actually, let's go over here. There's a solid dot. That means, according to this, we use the brackets. So we start at -3, and we're going to stop at 1. Now, what happens at 1? Well, it's an open dot, open circle. So open circles are parentheses over here. So, and that's all you got to do. That's pretty easy. Inequality. Well, for this, I have to let this shaded region be represented by some variable. Let's call it x. So if this little piece right here is x, my x's are in between -3 and 1, but include -3. So if x is in between two values, this is how I'm going to write that out. See, x, I'll put that like in the middle here. Here's my -3, and here's my 1. Okay? And what's the deal with these little symbols? Well, again, according to my little table right behind me, this -3 includes the point, so I'm going to go less than or equal to, and here it does not include the 1, so I'm just going to say less than. And again, I want to stress that with this, what I like to call in-between notation, it's always less, less. Now, it could be less than or equal to, but you never will put a greater than symbol. In fact, later on in another lesson, we're going to encounter a situation where they do become greater than. Ooh, then what? Well, you'll find out. But this is the solution for inequality notation. Now, what about set notation? Well, the key thing is set notation is very much like inequality. All I need to do really is include the braces. So the set notation would be something like this. The set of all x's such that, that's what the vertical bar means, such that, and then I pretty much copy this down. All right, so let's do that. I'll have -3 is less than or equal to x is less than 1. But now you don't really say it that way. How do we read this? We say it's the set of all x's such that x is in between -3 and 1 and includes -3. On the Lesson 2 quiz, there is a table where I ask you to fill it in, the different blocks of what's interval, inequality, the graph, set notation, all that stuff. And this is the first problem. If you're given just a number line with this on it, it's an open dot with a 6 and it's shaded toward the left forever, what would the interval, inequality, and set notation be for this situation? Well, if you have the number line, the rest is easy. Interval notation, again, using a little chart here to help us out here, we go from left to right. On the left, well, this goes forever that way. So it's going to negative infinity. So I want to start off by writing negative infinity. And again, always use parentheses, never square bracket, comma. And again, from left to right, it stops at 6, but it does not include it. It gets infinitely close to 6, but never quite gets there. So that's why it's an open dot. And again, we use parentheses for that. Once you have the interval notation, inequality notation is pretty easy. What you need to do is realize that this shaded region represents my x's. So what is the value of all these x's? Well, my x's are all less than. You see that? They're all less than 6. If they're greater than 6, they would be to the right. So I'm just going to use those, put those words into notation. My x's are less than 6. They don't include 6 because it's an open dot. And once you have inequality notation, the set notation just falls right into place. It's going to be the set of all x values such that x is less than 6. And then this problem is done. For the next problem, they actually give us just the interval notation, 1 to infinity, including 1. Before I do the others, I always do the number line. So let's just put 1 anywhere. Let's like say, oh, right there is 1. Now what happens exactly at 1? Well, that's a square bracket. So according to our little table here, square brackets get solid dots. So I'm going to put a nice, confident looking solid dot right there. And then what happens? It says, well, it's going to infinity. But then I just kind of shade over here. Again, this is the way you would just do it on paper. Can't have fancy. Let me just make that, maybe that number line, that arrowhead thicker. Okay, so it's all that. That's your number line. Okay, you don't have fancy visual aids to put on your test. You just write that out. Next thing is inequality notation. Well, again, this represents x, or any variable you like. I like x's. So what we do is, well, we need to describe, well, what's happening to the x's. Well, the x's are less than or greater than 1. You tell me, what do you think? Yeah, greater than 1. Yeah, so that's what I'm going to write down. X is greater than 1. Does it include 1? Yes. So again, according to our little table here, I love this thing. If it includes it, we put the little equal signs with inequality symbols. So this is greater or equal to 1. And the next problem here is the easiest thing in the world. The set notation is the set of all x values such that my x's are greater or equal to 1. And that's all you have to do. For this next part, we're given the inequality notation. X is in between negative 4/11 and 2/3 and includes 2/3. Based on that, we want to create the interval notation, the actual number line graph, and the set notation. Well, again, the strategy is try to do the number line first. So I'm going to just arbitrarily put down a couple of tick marks, and they're going to represent the 4/11 and the 2/3. X is in between, so it's going to be all these values right here. All right. What happens at the endpoints? We don't include it at the 4/11. So we make it an open dot. And at 2/3, we close the dot. Okay. Again, I'm showing you how you would do this on paper. Right. Now for the set notation, we pretty much have the answers. Oh, looking at us right there. All we need to do now is just add on a little extra to it. The set of all x's, or the set of all x values, such that, then we just copy this down. Okay, x is in between, negative 4/11, and 2/3. Close the braces, and it includes the 2/3. That's all you have to do for the set notation. Interval notation, again, you kind of look at this from left to right. We have an open interval here, so we start off with a parentheses, -4/11. We stop at 2/3, so you go 2/3, close bracket. And that finishes the problem. For our last problem, we're given the set notation. The set of all x such that x is in between 0.6 and 5.9 and includes the 0.6. Well, if I have this notation right away, I got the inequality notation, so I can just write that out right away. So I'll just write down the 0.6. I like putting the 0 in front. X is less than 5.9. So x is in between 0.6 and 5.9 and includes the 0.6. That was pretty easy. The next thing you want to do is the graph on the number line. So let's pick a couple of test intervals, like right there and there. I'm going to call this 0.6, and I'm going to call this 5.9. Now, some people, some professors, they insist you put the whole number line, put 0, 1, 2, 3, and 1, negative 1, negative 2, and the other. No, you don't have to do all that, really. Of course, if they insist on it, yeah, it's better. Remember, they override anything I say, okay? They're the boss. But this is just a fast and simple, straightforward, very visual way of representing information. And once I have these tick marks, again, x's are in between these values. And again, x represents the shaded part. So all this part gets shaded right here. All right? And what happens at the endpoints? Well, for here, we include our endpoints. So that's going to be a solid dot or a solid circle. And here, it's open. So I'm kind of going to erase that there and make that a nice open dot right there. And that's what it looks like on the number line. Now, once you have this, my interval notation, cake, baby stuff. Again, we're scanning this from left to right. So we're going to start off, well, I like to go over here. I'm going to start off with a square bracket and 0.6, comma, and we stop at 5.9, and we don't include it. That's it.